Okay, we are now in section 9.1. We're testing the difference for two means for large and independent samples. So we'll start off with the problem. Let's say a real estate broker in the San Gabriel Valley believes that the average number of sales made by her female agents is greater than that of her male agents. She would like to test this claim so that she can create a program to assist male agents improve their sales skills. She collects data to determine if her claim is acceptable or not. For this type of problem, we are comparing two population means, whereas previously all hypothesis testing was done by comparing a mean to a single numerical value. In making these comparisons, we have to ensure that the populations are independent of each other, meaning they have no values in common. So the notation that we use will be the following. So in this problem, mu sub 1 represents the average number of sales for female real estate agents, and mu 2 represents the average number of sales per male real estate agents. And so we will compare mu 1 and mu 2 when we perform our test. The broker decides to collect sample data from each of the two populations. So one population will be all the female real estate agents. The other population will be all the male real estate agents. So two samples will be collected from each of these populations. Okay, the data collected is the number of residential homes sold by female real estate agents and by male real estate agents. And then we have the results listed on the following page below. The population standard deviation for female realtors and male realtors is 4.0 for both populations. So the first step for the broker is to determine the claim and H naught and H sub 1. Well, H naught is always that the two means will be equal. Mu 1 equals mu 2. H sub 1 will be mu 1 is greater than mu 2. Mu 1 represents the average number of sales for the female real estate agents. Mu 2 represents the average number of sales for the male real estate agents. So that's good. That will be our claim. Our next step, we will use our normal distribution. It's a z-test because we're working with large populations, and we know the two population standard deviations. So we draw the normal distribution, we shade to the right, it's a right tail, alpha is 0.05, so let's look up our critical value, one tail, 0.05, all the way down to our z value, 1.65. That's the critical value, 1.65. Now we do have our data values here, so what we do next is we will type in each of these data sets into our calculator to compute the sample mean. Alright, so let's do that. So for the females, the sample mean was 11.9. For the males, the sample mean is 8.3. For both population standard deviations, it's equal to 6. I think there's a slight modification that we have to make over here. It should be 6. That's a typo there. So make sure you correct that on the paper. So 6, sigma 1 is 6, sigma 2 is 6, and then both sample sizes is 31. So N1, 31, N2, 31. So we have sample data for the female agents, sample data for the male agents. And now our next step will be to compute the test point. So this is our test point formula that we will be using for section 9.1. It's the difference in the two sample means minus the difference in the two population means divided by the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. And then something to take note of is the difference in the population means is 0, right? Because for H0 we assume that they're equal, so this value becomes 0, and that will be true for each time you compute the test point. So we take our sample information and we insert it into our formula. So mu1 minus mu2 becomes 0. We have the difference in the sample means, and we have our other information here. So just make sure when you're computing this in your calculator to use parentheses. Excuse me. And so we perform our calculations, and we end up with a test point of 2.36. So if we go back, we can see that 2.36 is after 2, so it falls in here, so your test point does fall into the critical region. So we make our decision, and that's going to be to reject H0. And then we summarize by stating that there is enough evidence to support the claim that the broker made. So she can initiate the training for the male real estate agents at her place of business. So let's go ahead and take a look at some of the key steps. So remember, when performing this test, you state the claim, determine H0 and H sub 1. And in this section, we're always comparing two means, mu1 versus mu2. Second step, you draw the normal distribution, shade in the proper number of tails. Let's just also mention, look up the critical value. Third step, compute the test point. Keep in mind mu1 minus mu2, always 0. You make your decision. If your test point falls in the critical region, reject H0. If it doesn't, do not reject H0, and then summarize the results. Let's go ahead and work out another problem. So there are a couple of problems for you to try here. We are going to work out this example here on the very last page. So let's assume that a person wishes to compare the difference in average wait times in minutes at two popular restaurants in Pasadena during peak hours. The person believes that there is a difference in average wait times between the two restaurants. Use a level of significance, remember that's code for alpha, of 0.01. One restaurant is called Houston's. So it's peak hours. The average wait time for a sample, 35. Population standard deviation is 5. And the sample size was 30 randomly patrons that were selected who are waiting for their chance to get a nice dinner at Houston's. The other restaurant is Granville. X bar, 45 minutes. Population standard deviation, 8. And sample size was 40. So our first step is, remember the claim states that there's a difference. So that means difference means not equal to. So when you set up your claim, the claim is mu1 is not equal to mu2. H0 is always equal to, no matter, in all scenarios, that's what we write down. Remember, when it's not equal to for H sub 1, that informs us that the test has two tails. So we have two tails. Next, we look up the critical values in table F. So let's get our alpha one more time. Alpha was 0.01. So two tails, 0.01, go to the very bottom of the column. So once again, two tails, 0.01, go to the very bottom. So we have positive 2.58, negative 2.58. Next, we take our sample data here and plug it into our formula. After we plug that information into the formula, mu1 minus mu2 is 0. We have the difference in the sample mean time, wait times over this information. You perform your calculations, and z should be negative 6.41. And that will definitely fall here in the critical region. So we reject H0. There is enough evidence to support the claim. And that concludes our video on section 9.1.